Hi everyone, it's Marika Lamoureux, and we are going to go through the second demonstration of how to hand calculate a dependent samples t-test. So this has nothing to do with anything, but I thought it was funny and I thought you'd enjoy it. So I hope that now you have a smile on your face and you're ready to start calculating a dependent samples t-test. So here we have a problem. I'll let you read it, and then once you're finished reading it, unpause the video, or pause the video, read it, and then unpause the video, and we'll carry on. Now we're going to state the null and the alternative. The null is that the TV does not influence learning, and the alternative is that the TV does influence learning. Here are formulas. I am not going to go through calculating the sum of squares. I'll assume that you know how to do that. For the D-score, again, if you need to see that happen, go back and watch the first video, and I encourage you to look at it and watch it and see me go through it step by step. But let's assume that you know how to calculate the sum of squares, that D-score. So now we have our sum of squares. We can calculate the degrees of freedom. Because there are 6 students, that means our degrees of freedom is 5. Now we can calculate the variance of the D-scores. If we know sum of squares, we know degrees of freedom, we can calculate the variance. And now we can calculate the standard error of the mean of the D-scores. We know the mean of the D-scores, so we can calculate T if we have the mean of the D-scores and the standard error of the mean of the D-scores. So that means that T is negative 3.2. And Cohen's D is going to be equal to 1.31. Back to the t-table. Our degrees of freedom is 5 because we had 6 people in our sample. And we are going to assume an alpha of 0.05 two-tailed test, which means that our t-crit is 2.571. Remember that our t-calc is negative 3.20. Now, at this point, you guys might be looking at those two values and you might be saying our t-calc is less than our 2.571 of our t-crit. And while that's mathematically true, it doesn't work when you have one of them, when your t-calc value is negative. So let's go up and look at this bell curve, which is why the bell curve is always printed with a t-table, so you can actually think your way through it and make sure that you're making the right decision about whether to retain or reject the null hypothesis. So the start of those gray bars is at the t-crit area. So when you have two-tailed, that means that the gray bar starts at 2.571 and also at negative 2.571. And if you look, then that would mean that negative 3.2 would fall in the gray area, just like positive 3.2 would fall in the gray area, which means that we are rejecting the null. If your t-calc value is falling in that gray area, that means you reject the null. So our t-crit is actually less than our t-calc because you're looking at the absolute value of t-calc, which means that p is less than 0.05. So again, we are rejecting the null, we're supporting the alternative hypothesis, and this is what it looks like written up in APA style. As always, if you want more help, I strongly encourage you to take advantage of any of these resources to get the support that you need.